Hello my lovely viewers, welcome again to Jeff Nino Mathematics class, a channel that makes mathematics easier for lovers of mathematics. Alright, today we have a question on the board, and the question is on standard deviation. Alright, it says if the standard deviation of 1x plus 1 to x plus 1 is equal to root 6, what is the positive value of x? What is the positive value of x? Now, when you're given a question like this, how do you go about this? First of all, we all know that the formula for solving standard deviation is the square root of variance, all right? And there is no way we can solve for variance when we don't know the arithmetic mean. So you see, we can't just start solving this question just like that. It has to go with steps, all right? It has to go with steps before we can get the final answer or the final value for x. So before then, let us begin this way. Let us try to represent the data given, in a table. Now we have our x, we have our x minus me, and then we have our x minus me raised to the power of 2. All right, this is actually the formula we're going to be using for solving standard deviation. Sorry, for solving variance, rather, for solving variance, because we said standard deviation is the square root of variance. Okay, now our x here represents the data given, which are 1, and then we have x plus 1, and then we have 2x plus 1. This is the value for x. Now in the second column we have x minus mean. Now we just brought out the values for x, but we don't know our mean. So before we can proceed in filling out this table, we have to solve for the arithmetic mean. So let's do that here. Now, solving for arithmetic mean, we have this mean is equal to sigma x over n. Now, sigma means summation, or you can simply say addition. Now, what are we adding together is the x given to us. So let's bring it out. Because we're going to be having something like this. 1 plus the other delta is x plus 1. And then the last is 2x plus 1. Okay, all over. Now, when you say n, it means how many data we are given. We have 1, 2, and 3. So we have all over 3. Okay, let's proceed. Now, our mean becomes, now we can't say 1 plus x because 1 and x are unlike things. But we can as well say 1 plus 1, which is 2, and 2 plus 1, which is 3. Adding up the numbers together. So we have 3 plus, let's add the variables now. We have x plus 2x, which gives us 3x. All over, we have 3. Now, something can go. 3 can cancel out the 3's at the numerator. So if 3 should cancel out 3, we're going to be getting this. Mean becomes 1. Plus, if 3 also cancel out 3x, we are going to be left with x. Now, some of you might be wondering, how is it possible to cancel out this? But let me explain something to you. When you have something like this, a plus b over c. When you expand, this is what it means. It means a over c plus b over c. So you will see that we have 2 c's at the denominators, but initially it was 1. Now why is it 2? This c is actually affecting a at the numerator, and it's also affecting b. Understand? At the numerator, so it becomes 2. That is why you see 3 was able to cancel 3, and 3 was also able to cancel 3, because we have 2, 3 at the denominator. Do you understand that? Okay, let's proceed. Now that we know that our mean is 1 plus x, what are we now going to do? Let's come back to the table. Now our mean now is 1 plus x. Now how can we get this column? Very easy. X here represents 1, x plus 1, and 2x plus 1. So it means we will subtract mean, this is our mean, from x, each of these data. So let's do that. Now, how can we subtract 1 plus x from 1? Let's give it a rough work. Now, this is our 1 minus. Now, our mean is 1 plus x. Now, first of all, we have to open the brackets. When we open the brackets, we are going to get something like this. 1 minus x. Why? Because minus times 1 gives us minus 1. And minus times plus x gives us minus x. So what do we do now? 1 minus 1 gives us 0, and 0 minus x gives us minus x. So automatically, what do I have here? Minus x. It's as simple as that. Now, let's go for the second row. Now, the second row says our x now is x plus 1 minus, don't forget that, our mean is always 1 plus x according to the question given. Again, let's open the brackets. When we do this, we're going to be having x plus 1 minus times 1 gives us minus 1, and minus times plus x gives us again minus x. Are you there? Now, x minus x is 0. 1 minus 1 is 0. So it means everything we have here is 0. It's as simple as that. It's as simple as that. So let's look at the last code, the last row. Again, same method, same pattern. Now, x there is 2x plus 1 minus our mean remains 1 plus x. Again, we open the bracket and then we have something like this. 2x plus 1 minus times 1 gives us minus 1, and minus times x gives us minus x. So let's go. 2x minus x gives us x, alright? And 1 minus 1 gives us 0. So what do we have left there? X. Okay. This is as simple as it looks. Now class, let us continue. Now that I've got to this column, mind you, we are not using this column, we are using this column because the formula for variance carries square. So let's go now. So for us to get this column, it means we're going to square each answer because here. So here now becomes minus x raised to the power of 2. Simple as that. So when you say minus x raised to the power of 2, what will it give to us now? X raised to the power of 2. Why? Because minus x raised to the power of 2 means minus x times minus x in two places according to the laws of indices. So minus multiply minus gives us a positive sign, and x times x gives us x squared. This is what we say, x squared. Now 0. Here becomes 0 raised to the power of 2, which of course gives us 0. And then lastly, here we have x raised to the power of 2, which of course gives us x raised to the power of 2, because it simply means x times x. Okay, let's get back to the question. Don't forget we are told to find the positive value of x. Now, apart from this data given to us, something else was given to us. What was that? Root 6. And now, who is the owner of root 6? Standard deviation. Because the question reads, if the standard deviation of this is this. So it means the owner of root 6 is standard deviation. So right about now, let us bring out the formula. Since we now know, Since we now know our variance. Okay, so now bring out the formula for standard deviation. Standard deviation says standard deviation is actually the square root of variance. Yes, that's the formula for standard deviation, the square root of variance. But don't forget the standard deviation was given a value which is root 6. So where I have standard deviation, I will substitute root 6. Okay, it's equal to. Now the question is, what is the formula for variance? Formula for variance, you know, there are two formulas. One, when the data involve frequencies, and then when the data does not involve frequency. As we all know, there is no frequency here, so I'm going to be applying the formula for variance when there is no frequency, which says sigma x minus mean all raised to the power of 2 over n. Cool. You see, now x minus b raised to the power of 2. This is what we have here. Okay, but now we need to add because of the sigma sign. So we need to add everything here to give us what will be here. So let's do that. If we should add here together, x squared plus 0 gives us x squared, and x squared plus x squared gives us 2x squared. It's as simple as that. So before then, you will notice that root 6 and root variance formula has something in common. What do they have in common? Roots. So what happened? The square roots cancel out. So when the square roots cancel out, what do we have left here? We have this. We have 6 left. This is equal to. Now don't forget that when we added everything together here on this column, we got what? 2x raised to the power of 2. Okay. All over our n is 3. 3. Because there are 3 data there. Over 3. Okay. So now what do we do here? Now we have to be 6 over 1 and cross multiply. 2x squared multiplied by 1 gives us 2x squared, and 6 multiplied by 3 gives us 18. Of course, we are looking for the value of x. So first of all, we have to divide both sides by the coefficient of x, which is 2. So here becomes over 2, here becomes over 2. Now when 2 should cancel out 2, I have x squared left, and 18 divided by 2 gives us a positive 9. Alright, so now we are looking for x. What do? We need to take the square root of both sides in order for us to cancel out the square. Or simply say, when square crosses the equality sign, it becomes square root. So here becomes x is equal to the square root of 9. Alright, now square root of 9 gives us what? The positive 3. That gives us the value of x that we were told to find. So class, we have come to the end of today's class. I hope you've learned something new. If this is the first time joining us, you're welcome. Don't forget to share, don't forget to like, and also don't forget to leave a comment. Till we meet again on our next class, keep on learning with Jeff Nino Mathematics class. Bye for now.